All right. Hi. Just checking to see if people can hear me. Can you hear me?
Yes, sir.
Okay, great. So it's 16:59. That's a few seconds away from class. So I suppose we'll start. But I see there's only 2 people in the room, which is a bit weird here. I'm not sure what that means, but anyway.
Let me just send a message in the group, sir.
Okay. Great. So I'm conscious of the time. I guess we'll just start with, is it 7 people? That's excluding myself. Great. So great. Before we start, there's a couple of announcements, things that I thought we should put out there. Granted, an announcement will be circulated, but I just thought I'd mention it right now. All right, great. So we are continuing off with our the correct thing here. Okay, great. So we continue our discussion of ICT 1110, which is term number 2, with lecture series number 9, which is loosely tagged as IO subsystem, or input-output subsystem. And incidentally, we are building up on ideas or concepts that we introduced in lecture series number 8, if you remember, when we were looking at so-called peripherals or input-output devices. Right? I don't know if you can see my screen.
Yes, we can.
You can hear me.
Yes, sir.
Clearly.
Not that clear, sir.
I'm not clear.
Yes, you are breaking.
This is a bit strange. Am I breaking for everybody, or it's just one person who's experiencing?
You are breaking.
Breaking.
Yeah.
You're
Okay.
breaking.
Yeah, now much better.
Okay. Let me try and see if I can swap. If I can swap my connection. I do apologize for the delay. All right, great. Is this any better than before?
Yeah.
Okay.
Yes, sir.
Great, thanks. Sorry again. This is the reason why we've always thought that screencasts work best for so-called e-learning or online learning. But anyways, so I was just saying that we continue with our discussion with lecture series number 9, and we're still, if you look at what we've been dealing with from the perspective of the von Neumann model, von Neumann architecture, we're still dealing with the input-output module, the input module and the output module, right? So we have thoroughly gone through the central processing unit. We hopefully should be able to wrap up with the input-output unit by the time we have the next interaction. And then we immediately dive into memory, right? In which case, after we're done with computer memory, we would have finalized the first half of the course, which is what we normally refer to as computer systems. And then we dive into the computer architecture component of the course. But before we start, like I said in my email, in my most recent email, we are done with the so-called offline screencasts. We want to experiment with a different sort of model. So going forward, we shall have these sort of online interactions. I mean, there are obvious pros and obvious advantages to this new model, right? The obvious advantage is, as we go through these lecture series, you get to have the opportunity to actually ask questions rather than wait until we have an interaction or wait until you can send email to Lighton or something. The disadvantage is something we just experienced a few seconds ago, or is it a few minutes ago, you know, where you tend to have interruptions due to technical glitches, right? Somebody wants to come in here, they're serious people. So that tends to disturb the flow, right? So it might affect the overall learning experience, but that's fine. We'll see how this goes. But so because we're transitioning to this new mode of this so-called live lecture, we're transitioning to live lecture sessions. I would like to propose that we have class on Monday and on Tuesday in addition to the Wednesday slot. So we will maintain the 17 to 17:45 slot on Wednesdays, but we need 2 additional slots. So what I'm proposing to you is a slot on Monday. Now, the reason I have multiple slots on Mondays and Tuesdays is because I know that it's entirely possible that there are some of you guys that might be busy in these other courses. So your task as a group, I'm not sure if Francis or Thelma, if either one of them are in the house right now, but your task as a group is to ensure that you engage all the various course minors to try and find out which slots are going to be appropriate. So either this slot on Monday or this slot on Monday, that's number 1. And then the other option is either you go for the Tuesday slot, right? The Tuesday slot, which is 15 to 15:45, or 16 hours to 16:45. If you can let me know before the end of the week, that would be good, because we intend to start adhering to these new slots effective next week. That's the goal. Obviously, we won't have class on Monday because Monday is apparently a holiday, right? So next class is hopefully going to be Tuesday. So I do hope people can think things through and then let us know which day. The class reps, I don't know if they're in the house here. Is this fine? Are there questions with regards to this transition process? Any concerns, questions that you might have, clarifications that you need?
Sir, the time has been cut down to 45 minutes.
Yeah.
Why?
That's a normal lecture is 45 minutes.
Oh.
A lecture is 45 minutes. You know, you don't. Ideally, it's always supposed to be 45 minutes to give you time to transition to another interaction that you might have. Like for instance, if we have these 15 to 15:45 interactions, it's entirely possible that someone amongst you might have a class at 16. So the idea is to give them time to transition to the other class. The lecture is not 1 hour, it's 45 minutes. We normally go overboard for these like Q&A sessions that we normally have, just because we assume that nobody is busy. But we're involved with these other courses where people people have other things that they have to do after class, right? So we have to stick to the time. Yes, is there any other questions or concerns about the transition process?
Mr. Lighton, kindly
Yes.
repeat what you said. I didn't get what you said because you took long to let me into the meeting.
Yeah, we took long to let you in because now here's the thing, right? You're playing background music and you don't want to listen, you don't want to follow the rules. You're supposed to log in using your UNZA assigned email account. The reason why you have to wait until somebody lets you in is because you're using your personal account, not your UNZA account. Everybody else in the room doesn't have to wait for Lighton. In fact, I found people in the room. But what I was saying is that we're transitioning from the model where we were producing offline screencasts to a different model where we will now have live lecture sessions. Now, because of the transition, because we'll have live lecture sessions, what that means is that we need 2 additional slots so that we adhere to the 3 lecture sessions that we're supposed to have in the course per week. We already have Wednesday. What I'm suggesting is we have either first slot on Monday 17 to 17:45 or 16 to 16:45 on Monday as well. So that's one slot number 1. Slot number 2 is going to be on Tuesday, either between 15 and 15:45 or between 16 and 16:45. The third slot is still going to be the one we've been having, the Wednesday slot. We're maintaining the Wednesday slot. Does that help in helping you understand what Lighton was saying before you joined?
Yes, sir. Thank you.
Okay. Any other questions or concerns? The test hasn't been marked yet. Hopefully it should be graded by the time we meet next week. And then we'll have a discussion, maybe a walkthrough of what we were expecting people to do.
So how about the quizzes? Will they also be marked by
Yeah,
next
the quizzes have been. I don't think so. Maybe not. I'm prioritizing the test here. The quizzes. Maybe we can make use of. This course still doesn't have a tutor. Maybe we can make use of the long weekend. I hope so. I think so. Tentatively, yes. By Wednesday, by the time we're meeting on Wednesday, yes, the marking would have been concluded for the tests and the quizzes. Oh, and then an email will be sent out for those of you that were inconvenienced during the botched test, the almost botched test, right? Those of you that attempted the test between 14 and 17 experienced intermittency when accessing Moodle, right? We are alive to that test, to actually reattempt the test. The vast majority of you did do that. Some of you were sending emails late at night and I was only seeing them the following day. Some of you only got in touch 2 days after. To be fair on everybody else, you'd have an unfair advantage if we had you write the same test. So if you're one of those people who were inconvenienced and you did not reattempt and still want to reattempt, you will have the opportunity to do this on Friday. There will be a completely new test. You have chosen to write another test, so you will attempt a completely new test. Different questions and related to what was in test number 1. So that will be on Friday. So if you're one of those who was affected, please prepare. Same style. The test will be made available between midnight and 23:59. You want to make sure that you pick a slot that's going to be convenient for you. All right. Unless if there are any other questions, we proceed, I guess. Or questions? Okay. Great. So, right. So what we're going to do, right, today, the goal is to try and understand exactly how this I/O subsystem works, right? Remember what we were discussing. If you think about this, what we were discussing was not necessarily a part of the von Neumann architecture per se, but it was, the discussion was centered around isolated electronic components that you would want to integrate with a computer system to enhance its capabilities. So technically speaking, that component isn't necessarily a part of the computer system per se. And so this lecture series is meant to discuss the so-called I/O subsystem. We want to gain a sense of how data gets to be transmitted from the peripherals to the central processing unit via the I/O subsystem. So we'll start our discussion by looking at some broad peripheral characteristics, right? And then we'll discuss core functions of the I/O subsystem. And then we'll wrap up the lecture series by looking at 3 specific types or techniques that are used to transmit data in between peripherals and the computer system. So programmed I/O, interrupt-driven I/O, and so-called direct memory access, right, DMA. Great. Again, this has become second nature. By the way, if you feel like you want to disturb Lighton, or if you want clarification, if you want to ask a question, feel free to interrupt. You don't have to wait until the end. There probably won't be the end here. Great. I just thought of something very strange here. Wow. I had an interaction. It has something to do with peripherals, right? I had an interaction with a 4th-year group that I'm working with. They're working on their capstone project, right? A research project, 5 groups of students. And I told them, you must be very careful how you use some of these peripheral devices, these peripherals, right? I don't know how many of you are following through with the scandal with the so-called, now we don't know if it's true, but the so-called Minister of Education, right? He, if it's true, he used a peripheral for the wrong thing. Now, if it's true, you want to be very careful. These peripheral devices can be dangerous when put in the wrong hands, right? I thought it was interesting, right? Can anybody tell us what peripheral device was likely used to leak those messages, send the messages? What sort of peripheral devices were used? We could have brought it on in the exam or the test in the exam, but I guess we'll ask the question right now. Anyone following through with the story?
I haven't followed it, sir, to be honest.
Yeah, so sorry, so what peripherals used? What peripherals were used in the process of the footage, the video footage of the images finding themselves online? Can we think of the peripherals that were involved in that process?
They needed a webcam to view what was going on in the screen.
Okay, there we go.
Yes, a webcam to view what was going on in the screen.
There we go. What else? Okay.
I think a microphone.
What else? There we go. Now the person who's saying I think a microphone, maybe watch the video. You want to be very careful. You'll be arrested. Apparently, you're not supposed to be in possession of the video. How do you know it's a microphone? Do you have the video? Okay, so microphone.
Sir, no,
what
I don't
else?
have the video.
Remember the thing. Oh, okay. No. But how do you know a microphone was used then? Apparently, for it to get to its destination, it's circulating on Facebook. Remember communication devices, right? They were likely involved. Those are things to think about here. We want to think about the bigger picture. Every time you come across some weird thing online, try and link it to ICT 1110. Think about this for a second. This is part of learning, right? Sadly, I don't know if this is something you discussed in EDU 1020. The idea that you want to be very careful as you are using these technologies, right? You want to use them for good, not for bad, right? Now, I'm not saying sharing footage is bad, but we can sit here and debate. Okay, great, good stuff. Don't be like the minister if it's true. All right, so we want this to sink in. Yes.
I was wondering about these slides that we are viewing right now. Will they be posted to the Moodle, or we're supposed to jot them down?
Now, boy, you can jot them down if you want to. I don't know how you do that with your phones these days, but they will be shared on the Moodle together with the footage itself. It's being recorded right now, so we shall share the slides together with the recorded video session. But jotting down is good, right?
Yes, sir.
I don't know if those of you that are doing, is it psychology? We understand that writing down, taking down notes helps you understand things better than waiting until you just play back the thing. Anyways, thank you for that question. We shall share these immediately after we wrap up with class. Great. So I want this to sink in, guys. This idea that we're studying an electronic device that ideally accepts input, processes the input, and then presents the information, which is the changed input, the raw data, presents it as output to an end user, right? Optionally, we now have gotten to a stage where we know that this data can optionally be stored into so-called memory, computer memory. Again, this is second nature. What we're saying is that this is the sort of interaction that takes place as an end user is interacting with a computer system, right? So you feed a computer system input, the input is processed by the CPU, and then optionally stored into memory. The rest we know, right? Great. Again, just to try and contextualize what we're talking about, this is still a discussion of the von Neumann architecture. We have had a thorough discussion on the central processing unit, a partial discussion of so-called input-output subsystem or input-output unit, although our discussion has largely been restricted to external devices, like I mentioned, the things that are here, right? The things that we use to interact with the computer system, right? So what we want to understand is how exactly does this interaction get to happen? From the time you type a key on the keyboard and when you get back a response, right? Is what we're interested in. Again, just to remind us of the role of this thing we are calling the input-output unit, we're saying it acts as an interface, right? An interface that makes it possible for the computer to receive input data and to present processed data in the form of output to an end user. And again, this end user can be a human being, it can be a computer system, it can be anything, right? So essentially what the I/O interface does is it just enables communication between a computer and end users, essentially, right? Again, we shouldn't forget here that if we think of the output and input from the perspective of so-called storage devices, right, then we probably would be in a position to appreciate the fact that the interaction is also can be viewed as being between CPU and main memory, right? Sorry, CPU and memory, or secondary storage in this case, not main memory. A question to think about, something I want you to think about here is if we were to include peripheral devices here, where would we say the interaction between storage devices and interaction between storage devices and the computer would be? Is it going to fall under, is it going to involve this component here, right? Interaction between storage device and this component, or would the interaction be, or would you perceive the interaction to be between this and this? Just something to think about. I don't know the answer, but I thought I'd pose that question anyway. All right, so it turns out that before we can start our discussion of how data gets to be transmitted, it's important to appreciate the different characteristics associated with these peripherals or input-output devices. And these characteristics are best viewed from the perspective of the specific type of devices that you're making reference to, right? So be it a device that you use to present sound, to provide input data in the form of sound, for instance, or text. Or another way of looking at the peripherals is from perspective of whether the peripheral handles input data, or whether it handles output data, or whether it handles both, right? Yet another interesting way of looking at the different characteristics of these peripherals is from the perspective of the rate of data transmission, right? What you will notice is that some of these characteristics, especially things like data rate, will typically change depending on the type of data that you're imputing to a computer system and how the data is being imputed, right? So you notice here that this screenshot here is appropriately presented in such a manner that you notice that there's a gradual increase in the data rates here. And we'll have a discussion about data rates very, very soon. Yet another way of looking at these peripheral characteristics is from the perspective of the type of data, specific type of data, right? It turns out that the type of data can be viewed as being either character-based, block-based, right? we have a lengthy chat about these different characteristics, so you gain an appreciation of what the fundamental differences are, right? Great. So in terms of devices, I mean, this was the essence of lecture series number 8. We went through a very lengthy discussion of discussing the various types of devices that are available out there, right? The different types of devices that are used to provide input data in the form of sound, text, video, images, or a combination of both, for instance. Devices that are used to provide output in the form of video, sound, right? An interesting idea that we raised is that a good way of viewing or of trying to visualize or understand the different types of data that a computer handles is from the perspective of the different senses associated with human beings. So your ears, your eyes, your mouth, right? All the senses with the exception of, I guess, your nose. These days, they're so-called brain computers, right? Computers that are able to pretty much pick up or interpret signals that are originating from your brain, right? So already your brain to a certain extent is involved in all of this as well. These are weird input devices, but nice way of looking at those devices. And we actually underscored this idea that the interaction between so-called end users and the computer system can either be human to machine or machine to machine, right? Classic example of human to machine is you, right? Classic example of machine to machine is instances where you get to interact with so-called communication devices. We are sending a compromising image via the internet to a girlfriend or boyfriend or something. What you're doing is you're implicitly making use of, or what's happening behind the scenes is machine-to-machine interaction as your message is being transmitted from your phone on the internet to the other person on the other side of the internet, right? Or somewhere on the internet.
Dr. Lighton, before you go any further, what do you mean by block-based or steady flow on the type of data, just the previous slide, behind on that one?
Well, so I just mentioned it's just essentially the way that the data is transmitted. We get to look at the different characteristics associated with block-based and character-based data in this very slide. We're getting ahead of ourselves. So we get to discuss it. Here, right? So we have a lengthy chart and we give examples of the specific types of data that is classified as that gets to be transmitted using so-called block-based devices and character-based devices. A nice way of looking at this, if you notice the characteristics, by the way, I know we're getting ahead of ourselves, but if you look at the characteristics, you'll notice that there's a pattern here. Typically, these so-called block-based devices will handle large volumes of data, right? So this would be like things like storage devices, because there's massive amounts of data that's being transmitted from the device itself to the computer system. All right. Great. So in terms of data, it turns out that this is an important aspect or characteristics of peripherals, right? Because it gets to determine exactly how fast or how quickly the signal gets to be transmitted from a peripheral device to the computer system, right? So essentially what these data rates you're seeing here, the highlighted portion of this slide is telling you the frequency at which data originating from these various devices gets to move from the device to the central processing unit. So it's at this rate, right? So you also notice that if you know the rate at which data is being transmitted, then you'd be able to derive how long it would take for the signal to move from the device to the CPU and vice versa, right? Data rates are typically high for block-based devices and devices that get to handle large volumes of data. So hard disks or hard drives, for instance, right? Your CD-ROM drives, for instance, your USB drives will typically have relatively higher data rates. Why? Because what you typically are doing when you're moving data from a USB to a computer is you're moving large chunks of data, for the most part, Could be like some movie that's 1 GB in size, right? Compare and contrast with the sort of signals that you're transmitting from the keyboard as you're typing one character at a time, right? Which explains why the data rates are somewhat slower. And in fact, the low data rates explain why it makes sense that you can interface a device like a keyboard or a mouse wirelessly, because the data rate is not a very important factor per se, right? Great. So essentially what these data rates do is they provide you with a representation of so-called throughput, the typical performance or the relative efficiency associated with the device itself. Essentially, what we are saying is how quickly, when we make reference to the throughput, is how quickly are we able to move a certain quantity of something, in this case, data, in between two different entities, right? So how the rate at which, or how quickly we can move data from a USB drive to a computer when you're reading the data from a USB drive tells you the throughput of that device. And in fact, your typical device will typically come with a label of so-called throughput. So when you're buying this device, the manufacturer will specify exactly how quickly data can be transmitted to and from the device. There's typically two data rates that are involved here, especially for storage devices. It's how quickly you can read from the device. So when you plug in a thumb drive in to your computer and you decide to foolishly access data direct from the USB disk, the rate at which you can read that data is normally specified by the manufacturer. It turns out that the rate is different when you are writing data to the disk, right? So typically, the throughput will be presented in twofold, right? The rate at which you can read from the disk when you are, let's say, playing back a video that's located on the USB disk itself, or when you're copying a file from the USB to the computer system. There's also a throughput, a value that is specified when you are writing data to the device, right? Two different things. Two different things that are typically associated with things like storage device. For a storage device, a classic example of a hybrid device, right? You are either extracting input, you are reading data from that device, or you are writing data to that device, right? By the way, this explains why these data rates here associated with these storage devices have a range, right? So this range, what they're saying here is that, and in fact, this example here is quite good. This flash drive example here, notice that there's a throughput associated with writing data, throughput associated with reading data from that device. It's much faster to read data from the device than writing data from the device. But anyways, throughput, right? We're essentially just, it's a measure, it's a metric that we use to ascertain how quickly we can read data from a peripheral device or write data or present input to the peripheral device. Another characteristic associated with data rates is
on that characteristic, Mr. Layton, on the same characteristic, like the one you have said, it is easier to read than write data. Why is it that?
Well, I guess I would have to clarify that because it's, yeah, so trying to see if I can come up with an easier answer here. By the way, you see, it takes longer for you to write to a device because you're doing two things. Think about this for a second. If you initiate a writing process, let's say you're copying, you initiate. If you are writing, let's say you're writing a file to a USB stick, what you're doing is you're doing a couple of things here. You are reading it from the computer system, right, where it's located. and then you are also going to have to write it, right? Save it onto the disk itself, not the device, but the disk itself. So it turns out that there's slightly more time involved in writing because of I/O operations that are involved, right? So you're taking into account the time it takes for you to read that data and also perform the I/O operation that involves writing the data to the device itself. This throughput, by the way, this throughput is nothing more than a derived metric that involves a quantity and time, right? Throughput is relative to time. So how quickly can you move X amount of data to a device? You are dividing the quantity you're moving over the time. If the time it takes, if the writing of data to the device takes slightly longer because you're in addition to reading the data from the source, you're also writing that data to the device itself, then it makes sense that the throughput is going to be slightly larger, right? I don't know if that makes sense here.
Oh, it does. Thank you very much.
There's a few more things involved in writing data to the peripheral, right? Which explains why this is somewhat smaller, right? So here's another way of looking at this, by the way. Look at this. If you think about this from perspective of now we have to be careful. We don't want to be like the minister here. You never know what might be projected in the students shared lecturer quote sharing video during lecture or something. But think about this for a second. Reading, right? If you're reading, let's say, 4 megabytes of data, when you're reading from a device, when you're writing the same quantity of data, you notice that what you're doing here is the time it takes, right? This will involve writing plus reading to a certain extent, right? So the latency associated with the writing process plus reading of the data from the source will increase the time it takes. So observe, if we're saying reading takes let's say 2 seconds, and assuming that reading from the source is going to take somewhat the same amount of time, what we're saying is that you have to take into account the 2 seconds plus the amount of time it's going to take to write the data to the device. Now, assuming writing, because of the overhead, let's say assuming writing takes 3 seconds, you immediately notice that the entire end-to-end process of writing data to the device would be 5 seconds, right? Think about this for a second. Reading here is 2 seconds. Latency, now this is just, we're making things up here. Latency for reading is going to be 4 megabytes divided by 2 seconds, which is going to give you, yes, you guessed it right, 2 megabytes per second. Writing, on the other hand, is going to involve you dividing 4 megabytes divided by 5 seconds, giving you a throughput which is much less. Do you understand why the throughput is much less when you're writing, right? There's a couple additional overhead involved here, right? So it will be 4 divided by 5. Now I'm making this up. You notice that our made up example has it's a less throughput associated with writing when compared to reading. Of course, it's not the idea of throughput is not as simplistic as we're making it sound, right? Because it turns out that you'd have to take into account other different things here. So you will notice that, anyway, that's fine. I hope this example makes sense. The idea that the reason why you're able to read at a much faster rate than
Sir,
write.
I'm behind with that example.
Okay. Where are you behind?
On the calculations.
Oh, maybe we got ahead of ourselves here, maybe. If throughput, right? Here's the thing. Throughput is nothing more than, if you look at these metrics, right? It's a measure of how quickly you can do something. Your throughput when you're walking from town, when you're hiking from town to home, is going to be your speed. That's your throughput. The distance, which is the quantity over how long it's going to take you. So maybe your throughput is hopefully going to be the average walking speed for a human being, right? But maybe less if you hike at a much faster rate. It's a measure of how quickly you can do something. In this case, in the context of what we're discussing, the throughput of your typical peripheral is how quickly data can be moved. If it's an input device, how quickly data can be moved from the device to the computer system, in this case to the CPU, right? Which is why, if you look at this measure, 100 bytes is it bits per second, PS per second, kilobits, is it bits or bytes? Kilobits per second, megabits per second, right? Gigabits per second, right? I do hope, oh, this is still in megabits. Megabits per second, right? It's a quantity, it's a measure, and this is a classic example here. When I was transmitting this ISO image, right? If you look at the size of the image I was transmitting was 1.5 gigabytes. The way that you compute how quickly you're transmitting this data is you look at it from the perspective of how much data has been transmitted in the unit time. So let's say after 5 seconds, after 20 seconds, for instance, I transmit this much data. Then I look at how much I've transmitted over the unit time. And then I come up with a measure. It's a fraction, it's a quantity over the time. So if we're saying throughput is measured by looking at the quantity over the amount of time it takes to transmit that data, right? Then what we are saying is that using this example, this hypothetical example, we can explain why the throughput for reading from, this example is a USB, by the way, example of USB, a hypothetical USB, right? We can showcase that it would take us a shorter period of time to transmit the same amount of data from a USB than it would take us to write to that USB, because writing involves additional operations, I/O operations, right? So assuming, just for simplicity's sake, assuming that it takes 2 seconds for you to just read 4 megabytes of data from the USB stick, USB drive, then it makes sense that it's going to take you slightly longer to write data to the same drive or disk, right? Drive and disk, two different things. It's going to take slightly longer because you're no longer just reading that data from the source, but you're going to have to spend the time writing the data to the USB stick. So what we're saying is we're just making things up. We're saying, assuming it takes 3 seconds to write the data, the latency or the time it's going to take for the entire writing operation is going to be 3 plus 2, which is 5 seconds. Now, for the same quantity, reading takes 2 seconds. The entire end-to-end process of writing will take you 5 seconds. Throughput for reading is going to be the quantity, which is 4 megabytes, over how long it takes you, which is 2 seconds, and it gives you 2 megabytes per second. Writing, on the other hand, is going to be the same quantity, 4 megabytes, divided by the time or the latency, which is 5 seconds, which gives us a much lower throughput. Does this make sense now? Oh, I don't know if people are still there.
Yes.
Yeah, so don't worry, we have these things, by the way. Your mobile device, right? I don't know if you've noticed this, but on your mobile device, on the top strip there, if you're using Android, and we have an example about this, your mobile service provider like Airtel, MTN, or Zamtel will tell you to say the rate at which data is being transmitted to your phone. If you have data enabled, like in my case right now, it's 48.8, I guess this is kilobits per second. These are all quantities, right? These are all measures throughput. Observe Lighton. Lighton has 2 connections right now. He's currently connected to, he's tethering his phone. So data, when I'm connected to the internet to have this class with you guys, the throughput of the rate at which data by sound and the image or the screencast is being transmitted from me, from Lighton to your device is at this rate. Do you notice this? Now, granted, we are simplifying this. Usually, your mobile service provider will tell you what's called the download speed and the upload speed. The upload speed is usually much faster. If you notice the arrow here, I don't know if you can see this, the down arrow tells me that I'm downloading data at this rate, 22 on average, 24.0 kilobits per second, but I can upload data at a slightly larger rate, right? This is all throughput. Throughput is from the perspective of what sort of data you're transmitting. So there is a throughput associated with how quickly the sound is coming from the microphone that I have hooked up to my machine to my computer, right? Because it needs to be processed. How quickly is it getting to the computer? How quickly is the sound coming from the computer to my earphones? Because I'm using my earphones right now to listen to some of the questions you're asking. How quickly is the data being transmitted from Lighton's computer to the internet, right? So that you can play back, you can listen to the sound as Lighton is lecturing right now, talking to you right now, is at this rate. It's upload speed. Do you understand this? It's a throughput, it's just a metric that's relative to the quantity and the unit time involved. Simple. We have examples, don't worry about this. It will make sense very, very soon. It turns out this is extremely important. When mom and dad ask you, do you think we should buy Airtel bundles today or MTN bundles? Now, as a smart ICT 1110 student, you should know, depending on where you stay, which mobile service provider, on average, in your location, has a higher throughput in relation to the download, how fast you can download data. These are different, right? I'll showcase an example. If you notice my MTN connection right now, this is an example. I'm going to go offline briefly for a few seconds. I'll connect my microlink, which is it's contented right now because I've gone beyond my so-called turbo allocation. But hello, can you hear me?
Yes, we can.
Microphone testing 1 2 1 2. Hello.
Yes,
We can get you, Mr. Wright.
Can you hear me?
Yeah.
Yes.
Oh, great. Now notice once I swapped, right? You notice that my other connection. Notice the download speed now, much lower, right? In fact, it's like half, right? I'm downloading data. Yeah, I'm downloading this data at 5 kilobits per second, but of course the upload speed is much higher, right? It's a throughput, it's a measure. By the way, I'm not very clear because my connection, my microlink connection, my broadband connection is contented right now. So I do apologize, but pause for a few seconds. I'm going to switch back to my much faster connection. Microphone testing 1 2 1 2. Can you hear me?
Yes, sir.
Okay, perfect.
Yes, sir.
Right.
Yes, sir.
So now, as a smart ICT 1110 student, you should be able to make an informed decision. Taking into account, very, very soon we'll look at things of cost. Taking into account, it's not just the cost, right? It's how quickly, how fast you can download data, right? So these are things to think about. Throughput is nothing more than just metric that measures how quickly you can transmit data from one point to the other. All right, so I'm wary of the time here. Maybe, I don't know, can I suggest that we pause? I'm looking at the time. Maybe we can do this. Can we? Okay, let's finish. We've already started the data rates, and then we'll look at an example next week. So we're saying an important metric that you need to take into account as you're computing so-called throughput or the data rates is the latency. So response time, how long it takes you to move a certain quantity, a measure, right? Because remember, what we're saying is throughput is nothing more than it's a derived metric that takes into account a measurable and the unit time it takes to move that quantity. So it makes sense then that the key ingredients for you to compute the throughput is the measurable itself, the thing that you're transmitting, in this case is the data. The other important thing is the latency, how quickly you're able to move the data, right? So latency is nothing more than a measure of how quickly you need time involved or that elapses for you to complete the task. So it could be transmission of data from one computer to another remote computer on the internet, transmission of sound data from the microphone to the computer system itself. There's different ways of computing these things depending on what sort of data you're computing here. There are some inbuilt software applications that you can take advantage of. I like using Audacity. I don't know if Audacity has a way of trying to figure out exactly, probably not, but start monitoring. So, well, I guess this is a horrible example. I don't know if you can still hear me, but I was trying to see if there's a way of using Audacity to try and figure out the rate at which data is moving from my microphone. It's just this small little visualization. You notice as I'm speaking through the microphone, the application is mimicking the sound waves, right? The transmission of the sound from my mouth to the microphone as it's being transmitted into ones and zeros into data, right? That the computer can understand, because the computer does not understand sound, right? The sound has to be converted into data. I'll try and see if I can find an application that can make it a lot easier for you to measure how quickly the sound is moving from the microphone to the computer system, right? But for you to measure that quantity, you'd have to take into account the data that is being handled, in this case, the sound, right? And how long it's taking, right? It's usually a lot easier for you to measure the throughput when you're yes, sir. It's usually a lot easier for you to measure the throughput when
Does it also matter with the type of data? Like, for example,
the problem, you probably want to.
So
you have two devices connected. You have two devices connected. You want to mute the one you're not using. There's a bit of echo.
Oh, sorry, sir. Yes, as I was saying, does the size of the data also matter? Like, for example, you're moving a video file, which is a combination of images and sound. Does it also impact the size of the data, or the size of the file?
What do you mean? Does it impact the size of the file? Could you elaborate more on that?
Like, for example, if you're moving a song, an MP3, it doesn't have any images. It's only sound only. And if you're moving a video, a song plus images, is it that the one with sound and images will be larger in size compared to the one with sound only?
You mean, is it going to be larger in size, or is it going to be transmitted much faster? These are two different things.
Oh, yes. Is it going to be transmitted much faster?
Well, the interesting thing, and we have a brilliant question, by the way. Pause for a little while here, by the way. I see a lot of comments here. If you have a question, Lighton will rarely, I don't want to be like a minister in his memory here. Lighton will rarely read through this, so please use your microphone if you have a question. If you can't use your microphone, best you have a colleague read out your question. You type it in and you have them read out the question. But brilliant question there, right, Mr. Leandro here. The computer, you soon discover, interesting thing about the computer, right, is it doesn't know whether the file you have is made up of sound or it doesn't care actually. The computer doesn't care whether what you're transmitting is sound, is video and whatnot. As far as it's concerned, what you're transmitting is a series of, ones and zeros. Continuous stream of ones and zeros. You'll soon see. This is where application software becomes really important. Why? Because using application software, you signal to the computer to say, you want to explicitly have it interpret this data using the currently loaded program instructions. the program instructions will learn into memory. So it doesn't matter. This throughput metric is relative to the size of the data. The rate is going to be the same irrespective of whether what you're transmitting or moving is sound. Only the combination of sound and images, which is so-called video, whether it's an image alone, discuss, right, to understand how exactly these different types of data get to be encoded, right? We get to do a bit of experiments here. You notice that it doesn't matter whether it's sound. I wonder if I can give an example here. Observe, and the thing is oh, we have to be careful. I don't want to be like the minister here. If I try, I'm trying to see if I can move a large file. Observe, image, MP4 file. Now this is a bad example because I'm going to be moving this onto the hard drive, right? One location from the hard drive to observe. I'm going to move this here. If I move this file, right? If you look at, okay, it's a horrible example, but if you look at the rate here, I don't know if you can see, I have the total size of the quantity I'm transmitting, right? Where is the time? There's no time per se here, but I have the throughput. Now this is a bad example that might or might not work. What I expect is a sort of situation where if I try and move a completely different type of data, this is a zip file, by the way, this is a piece of software. If I move it, it should have a throughput that should be somewhat closer. The reason there's a difference in the throughput, by the way, 116 here and 126, is because there's a whole bunch of things that are running on Lighton's computer right now. They influence the throughput of the data, the transmission of the data. But you notice that the rate is the same. It's going to be the same. Why? Because the computer doesn't care whether you're moving sound, images, the image by the minister or anything else. As far as it's concerned, what you're transmitting is something that's encoded as ones and zeros. That's all. I hope that answers your question.
Yes, sir, it does.
Great. So with that being said, taking into account the key ingredients of computing a throughput, which is a measurable, the quantity, and the unit time, we notice that the equation that we use to determine these rates here that we saw in this image here is the size of what you're transmitting over how long it takes. Now, usually by convention, the how long is measured in seconds. It's always in seconds. Data transmissions are always in seconds, irrespective of the size. It's always relative to seconds, right? If you notice this throughput here, BPS, bits per second, kilobits per second, megabits per second, gigabits per second. The unit time is usually relative to seconds. The quantity, the measurable itself can be represented in either bytes, in kilobytes, in megabytes, in gigabytes, in terabytes, in petabytes, right? But the unit time that is used is always, by convention, it's always in seconds, which is why if you look at your phone, if you look at how fast you're transmitting data from your USB stick, it will always be by convention relative to seconds. But because this is a derived attribute, this could otherwise be represented in minutes if you want, right? Especially in instances where what you're transmitting is a large thing, right? That takes maybe days to transmit. Great. So you notice that it's a simple formula. Throughput is going to be the measurable over time. Simple, right? Right, and so it turns out, I think we'll pause for now and then we'll continue this discussion by just briefly looking at the conversion or the different representation of this measurable, right? The different units that are involved here. How we get to move from bits, these ones and zeros, to so-called bytes, to kilobytes, megabytes, gigabytes, petabytes, zettabytes. We'll continue our discussion hopefully on Tuesday if you decide as a group that we'll meet on Tuesday. Unless if there are any questions, I think we'll pause for now. Are there any questions? Okay, great.
We have
Thank
understood,
you very
sir.
much. If you are like Mr. Kakana here, who was downloading the video by the minister, hopefully you were taking note of how fast you were able to, the throughput, when you were downloading the file. If not, delete the file and then re-download it and then try and see if you can figure out the throughput. I'll see you when you see me. Hopefully it's going to be on Tuesday. Stay safe and cheers. Thanks.
Oh, sir.
Oh,
Yes, sir.
Are you going to put the notes today?
Yes, I will upload. Now, I do hope when I'm uploading the notes, maybe I will measure the throughput of how fast I will be able to upload the notes. Maybe we can we check on Moodle if, don't go anywhere. Maybe we can, don't go please. Maybe we can check on Moodle how quickly we can do this. I hope Moodle has a way of figuring out how fast you can move things here. Observe, right? If Lighton goes to the site and then tries, maybe it will, maybe it won't, probably not. Lighton will navigate down to, come on. Lighton will navigate down to, usually these applications will mimic, and it's easy for you to build an application that mimics these things you're calling, that mimics how fast you can move a file. It probably won't, which is quite sad really. But I was so hoping that it would enable us figure out, measure the throughput. Somebody is concerned about this. What Lighton will do is we'll upload the notes right away. I hope you're still there. Let's see if we can figure out the throughput. Where are you? No, the only thing Moodle does is, you notice this, it's a visualization telling you that it's uploading, but it's not showing how quickly the file is being transmitted. I was hoping I could showcase, anyway, it won't work, that's fine. I was hoping I could showcase exactly how fast the upload takes. This is all, and these are important metrics, by the way, because how fast something takes is going to make a difference between Lighton deciding to say, I will use my MTN connection to transfer or to upload a large file. If it's fast, if it needs to be quickly done, then maybe Lighton will decide to say, you know what, I think I will not use MTN, I'll switch to a much faster connection, a connection that has a much larger throughput. I do apologize that Moodle doesn't have this facility, but Mr. Posa, the notes have been uploaded, so you'll find them right away.
All right, sir. Thank you.
Before I leave, before I finish this, are there any other questions? This is quite sad, but any other random questions you might have just on HiTest?
sir,
Yes, sir.
when you're sending a video to a friend via WhatsApp, you are literally, you are uploading it, right? You are literally uploading because the person will have to download it, right?
Yeah, although it's not as simplistic as that, right? It turns out that the way these applications work, right, is sometimes even though you are sending the file, but you would implicitly be getting back some sort of response from the application. And so implicitly you're downloading small little portions of data, right? Small data, right, in the form of responses. But yes, you're uploading the file. When you're sending it, you are uploading it you're uploading it because you are literally like sending it onto the other side. So yes,
Right.
yes, sir.
So meaning throughput can be calculated from there, right?
Yes. How fast are you uploading it? That's the throughput as well. Right?
Yes, sir.
Yeah. That's these are all good, smart questions, by the way. Thank you for that. Any other questions before I'm done with this? I wonder if human beings in the future will be asking, why were they using Moodle or something, or to do this? Oh, this is not working. Or so why did the Minister of Higher Education in Zambia, maybe it will appear in the archives, in the museums, right? 100 years from now, people will be able to, I'm sorry, I'm giving the example of the minister here, but I think it somewhat helps to put things into perspective when you latch onto things that people can easily relate to, right? So like I do hope that the examples I was latching on to, like the minister and me swapping from these other connections that I have, I hope they were they were helping you understand this idea of throughput, right? Data rates. Unless if there are any other questions, I think Lighton will log out now and leave you to do your thing. I hope you won't be doing what the minister was doing. Thank you. Good night, and please stay safe. See you next week.
Good night,
Same
sir.
to you.
Good night, sir. The
Minister Kantukono. Minister Somone. Ah.
Can have a cute guys.
Don't be like the minister.
Ah.